Solid Edge's best-in-class simulation capabilities provide design engineers with powerful tools to help digitally validate their designs to build better products in less time by front-loading the simulation process. Improved visualization of the assembly connections allows users to clearly see what parts and faces are connected together. Harmonic studies allow the validation of vibration levels within a structure, allowing designers to ensure better dynamic characteristics in their products. The harmonic study can utilize the resonance frequencies from a previous modal study. Any of these frequencies can be added, along with the other appropriate inputs such as start and end frequencies and damping coefficient. When the study is solved, the different result cases can be viewed and clearly navigated. In addition, users can probe individual elements in the mesh to plot a graph which shows translation versus frequency. And of course, reports can be easily created to communicate the simulation results to a wider audience. These include all study properties, results, and saved graphs. For transient heat transfer studies, an adaptive results option fine-tunes the number of increments calculated, saving valuable solve time. Functions can be created to more accurately simulate the real-world operation of products. Much like with this motor, applying factors to different time increments. Thermal connectors also allow for the definition of thermal contact resistance. Probing some of the nodes and creating a graph clearly shows the impact of the function by plotting temperature versus time. Advanced motion analysis capabilities provide tools to ensure the digital validation of mechanisms. Here, parts are automatically added to the simulation based on their existing assembly constraints. Then the appropriate forces are applied to the relevant parts before simulating the study. 3D contact can be defined between components, such as the clamp arm and hydraulic damper, with complete control over material impact and friction characteristics. Another quick simulation now shows the mechanism working as expected. Plots for parts and assembly joints can be created to investigate velocity, acceleration, momentum, kinetic energy, and more. Additionally, the forces and their directions can be automatically applied to a static simulation study. These are pulled directly from the motion study. Solving the study shows the results in the context of the assembly. Using flow simulation, we can examine the performance of this rotating drying chamber. The arms rotate around the model, and air is used to dry the part. Analyzing the nozzle performance allows visualization of the different flow characteristics on either side of the model. The flow velocities on the surface of the model can be visualized. So too can the air jets hitting the part. With the arms rotating, the surface velocities move with the air jets. And with the flow trajectories result plot, it's easy to visualize the directions of the airflow as it moves toward the model. With Solid Edge's powerful simulation tools, design engineers can digitally validate their designs to build better products in less time.